Alright, this is the last section, basically section 4 of the pH scale. Alright, the pH scale is used to express really small numbers, or the P scale basically, used to express really small numbers, so we don't have to use that like times 10 to some power, so like times 10 to the 7th, or negative 7th, or times 10 to the negative 10th, or whatever. We can just use like a 7 or an 8. It just makes it easy. And it's based on common logarithms is the key here. So, and I know that kind of sounds scary. We say, oh my gosh, this is logarithms. But really, if you can use a calculator, you don't really have to per se understand logarithms to do this basic logarithm stuff. So it sounds scary, but it's really not. Okay, so we're just going to take you through some examples of how to do some basic logarithm stuff. Okay. Alright, so first of all, pH. pH is the hydrogen ion concentration, and so notice the equation. pH is equal to the, notice here's our first negative log of the hydrogen ion concentration. So what you're going to have to do here to get that is you're going to plug in your calculator, and I'm giving you an example down here where the H plus concentration is 1 times 10 to the negative 9th. So basically your equation is pH is equal to the negative log of our H plus. So in this case the concentration is 1 times 10 to the negative 9th. So that means in your calculator, and of course everybody's calculator is going to be different, so it depends on what calculator you have. So mine, I would plug in negative log 1 times 10 to the negative 9th. And then it should, no matter what calculator you have, you should result in a pH of 9. Okay? And so that's your answer. pH equals 9. Now, that tells you a lot about the solution. Like before, you could tell it's acidic or basic or neutral by, how much, if the hydrogen ion concentration was greater or if the OH concentration was greater. Well, here you can tell by the pH. If the pH is 0 to 7, then it's acidic. If it's 7 by itself, it's neutral. And then if it's, I guess you should really say up here that it's 0 to 6. And then if it's 8 to 14, then you have a base. So this solution over here, since it's 9, would fall in our basic category. So it didn't ask for that, but this would be a base then. Okay. Alright. Here's another one. Now this one's a little different though, because notice that they are asking for the pH, but they give us the OH concentration. So this one we have to do a little bit more work for. Now this one, they give us the OH, so we actually have to use our equation that we have before, which is this. Okay, where you have Kw equals H plus times OH. And so we know that that's 1.0 times 10 to the negative 14th. And that's equal to, oops. So we don't know our H plus. Okay, they gave us our OH. Okay, so now we just divide each side by 1.0 times 10 to the negative 6th. So 10 to the negative 14th times 10 to the negative 6th, and so that one I get my hydrogen ion concentration is equal to 1 times 10 to the negative 8th, because I can't use the pH equation unless I have hydrogen ion concentration. And so now I would plug into my calculator the fact that the pH is equal to the negative log of 1.0 times 10 to the negative 8th. And so in this case, my pH is equal to 8. So again, this would be an example, not that I asked for it, but this would be a base because it falls between that 7 and 14 category. Okay, hopefully not too bad. Alright, next one. Now notice we're switching the equation up. They're asking for pOH. And so this is where you're taking the logarithm of the OH concentration. And so again, this one, they are saying you have come down here. Oops, still not low enough. You have a pOH is equal to, it's the same equation, it's just instead of the concentration of H plus, you have the concentration of OH. And so I'm just going to say that the pOH is equal to the negative log of 1.0 times 10 to the negative third. Okay? And so my pOH is going to be equal to 3 in this case. So the thing about this, though, is that you cannot determine if it's acidic, basic, or neutral based off of the well, you can. You can't determine if it's acidic, basic, or neutral based off of, this particular number. You have to actually do something else, and that's what the next example is about. The next example is saying, calculate the pOH if the pH is 7.4. Well, this is where a new equation comes into play. The new equation says the pH plus the pOH is 14. So we could find what the pH is, meaning we can determine if a solution is acidic, basic, or neutral, given the pOH, because we know that all you have to do is basically take the pOH, subtract it from 14. Or if they want to know the pOH, we don't have to do a bunch of steps. So basically what we're saying here is that in this case, the pH, where'd it go? The pH plus the pOH is equal to 14. And they gave us the oopsie. They gave us the fact that the pH is 7.4. So I want to find the pOH. Well, just subtract this 7.4 over, right? So 14 minus 7.4. So pOH is equal to 14 minus 7.4, which is 6.6. And you could do the opposite too. Like if they would have given us the pOH and I would have figured out what the pH is, I could have just subtracted that over too. So that really helps us because we would have had to do the whole opposite process and a lot of different steps just to get back and forth to different things. Now, next example. What else are they going to do? They're going to have you go backwards. Alright? And so to go backwards, they're going to give you, like in this case, they're going to give you 7.41, and we know how to use this equation for the pH. And sorry, I didn't take this equation off the top. You really don't need this equation. I split this slide up and I put multiples, so this is just kind of gobbledygook, so kind of ignore that. I apologize. This is one where they're having you go backwards. You're actually using, in this case, the pH equation, so I guess I should write that up there so it's a little less confusing. Negative log of the H plus. Okay? And they're having you go backwards, so they're saying the pH of this blood is 7.41, and they want you to go backwards and say, hey, what was the initial concentration? Meaning, what was the negative log of the H plus? Let's go backwards. Okay? And so, what I'm going to do here is I'm going to insert, and I'm actually going to show you on my calculator how to do this because I think it's a little bit easier to show you. Okay, and so I'm going to show you on my calculator. I'm going to come back and I'll show you how I actually get this answer of H plus equals 3.89 times 10 to the negative 8 molar. Okay. Alright, so here's my calculator, and I know it's not as clear as it should be, but if I zoom in here, there you go, you can see somewhat, it's a little blurry, you see my log button, and then above it, which again is still a little blurry, there we go, you can see it, there's a 10 to the X button. That's what we're looking for.
The 10 to the x button allows for us to do the opposite of a logarithm. It allows for us to get back to the base of 10. So what I'm going to do is then I want to produce to get the pH back to like a number of 1 times 10 to the something. So what I'm going to do is I have to hit second on my calculator, then I'm going to hit the log button, and that then produces this on my calculator. And then I type in the negative of my pH, 7.41 in this case, and I hit enter. When I do that, you'll see it does 10, negative 7.41. And the reason it's negative is because the equation is the negative log. So the negative has to go back with the pH. And so notice this is my answer. So 3.89 times 10 to the negative 8. Again, that was second log 7.41, enter. And then that's, oh, I forgot the negative. It didn't hit the negative. Second log negative 7.41. And there you go.
Okay. Alright. And so we're going to do the same thing for this one with the POH, where you have the POH. So it's the same equation, and so except for POH, right? So you have the POH, which is, this is equations written at the top, but so I'll just go ahead and write it again though, so it's real clear what equation we're using. But this one, they gave us a POH of 6.59, and they want you to figure out what that OH is. So again, I'll cut away, I'll show you how to put this in your calculator, and show you how to use and find out how to get the OH concentration to be 2.57 times 10 to the negative 7th molar.
Alright, so for the last example, just to show you how I would plug that one in my calculator, I would do, again, so I would do second, and then I would hit the log button, and then so the POH was negative 6.59, and so you can see that on here, and then I would hit equals, and then 2.57 times 10 to the negative 7th, and so that's how I got that answer. And so that's how we would do the last one.